Good morning, everybody. This is Leonid Knizhnik with the lecture about two new topics. First topic is display, the digital display that's used by computer. And second topic will be networking. Let's start with the first one. Folks, display is the screen, like TV screen, that can place the image from the computer. This image has artificial nature and it's initiated by the digital source from the computer. So usually this is rectangular screen that actually has so-called aspect ratio. This is proportion of the sides. Before 5 years ago, that was very popular screen, which was aspect ratio 4:3. But now, most popular screen is 16:9. Size of the screen. Size could be very different, beginning from 6 inches and finishing with 72 inches and more. It's just question of technical possibility. The image that you can see on the screen is actually created by dots. Dots on the screen named pixel. So one dot is pixel. Folks, how image could be created by the dots? Very easy. When dots are very small and the quantity of dots big enough that you cannot recognize the dot by itself, then you can probably create an image like this. Take a look. I will make a dotted image like a letter A, and then you will see quite letter A. Let me do this again and again and again. Look, this is letter A. Definitely when the vision became quite blur, then you will see perfect letter A, like no dots. But these dots are literally existing. If you pick up magnifier lens and apply it on the screen, then you will see these pixels. Now, how many pixels in a screen? This parameter actually named resolution. Resolution for the screens that were a long time ago was very small. That the first resolution I remember was 640 by 480 pixels. Definitely the image of this resolution is very rough. It's very pixelated, how we call it. But new computer screens, they usually utilized the resolution named HDTV. And HDTV is 1920 by 1080 pixels. 1920 by 1080. But this is not a limitation, folks, because this actually, if you multiply this by that to calculate total number of pixels, then you will be able to get something around 2 million pixels. 2 million pixels, folks, is 2 megapixel. 2 megapixel screen. Now you understand why digital camera that utilized digital sensor also measured in megapixels. By the way, the regular resolution for contemporary camera is greater than 20 megapixel. The human eye actually also works with megapixels because the retina created with the pixels. And how many pixels in the human eye? People told me that this is 98 megapixel in human eye. So human eyes are very high resolution optical device. Now, folks, if there is more pixels, for example, 4 megapixel, they call it 4K. The resolution for 4 megapixel, I will tell you later. Now, question, how these pixels are organized? And I will tell you, folks, that pixels are rows and columns on the screen. How many columns? 1920. How many rows? 1080. So that side will be 1080, and this side will be 1920. Folks, the first displays, they were black and white. Actually, not quite black and white, but they were shades of gray displayed. So they can display like old-fashioned black and white photographs. How they did it? The first pixels on this display were controlled by 1 byte of information in the computer. 1 byte of information. So, folks, that pixel relatively connected to 1 byte. But we know 1 byte is 8-bit, right? So we can see 0000 and 0000. That content of 1 byte usually give you a very low light, begins 0 brightness. 0 brightness will give you the black color. If you take something in the middle of the content of the byte, let's say we will take byte that connected to this pixel, and this will be like this: 0111 0110, something like this, in the middle of the total number of variations that in the byte can be. So how the pixel connected to this byte looks like? Folks, this is gray pixel. I'll put it dotted gray pixel. And eventually what's happened if I connect byte, that will be total ones: 1111 1111, and that will be white pixel. So you can see the brightness of the pixel is regulated by the corresponding byte in the memory. So if we're talking that this display 1080 by 1920, actually 2 million pixels, every pixel must be connected to 1 byte, so the entire video memory, but this is specific memory that actually connected to the display, video memory, must be 2 megapixel multiplied by 1 byte, that will be 2 megabyte. So this screen, to display all the bytes, need 2 megabyte of memory. But that will be one static picture with resolution 1920 by 1080. But we know also that picture is colorful. How colorful picture could be made on the display? Let me try to explain. When people tried to make colorful picture, they said all colors could be done with the true basic colors, with the 3 basic colors. So they made pixel like this, oval, and they put 3 colorful pixels inside. So folks, what pixel's nature? It's like little flashlight, microscopic flashlight. And they painted the filters of this flashlight with the 3 colors. One became red, next green, and the last one is blue. Red, green, blue. So folks, I will write down RGB. So when you see RGB abbreviations, that meaning color components of 1 pixel in the computer screen, also in the digital TV. Red, green, blue. Definitely each sub-pixel, but every of them named sub-pixels, because pixel will be tri-subpixels. So 3 subpixels. Every subpixel is connected to its own byte. Let me connect one. So I will connect red one to the byte, exactly like here. Then green one I will connect to its own byte, and the blue one will be connected to its own byte. Byte, byte, byte. So that is byte, and that is byte, and that is byte too. But folks, one question will be on the exams. If we have 1 byte per pixel, how many shades of gray this pixel can display? This is about this diagram. Folks, we know that number of combinations in the pixel, which equal number of combinations in a byte, is equal to in the power of n, where n is equal number of bit. What is the number of bit in 1 byte? 8. So Q here will be 2 in the power of 8, 8-bit, or that will be 256. So in this kind of diagram, number of shades that can be displayed per each pixel, per each 1 pixel, will be 256 shades. 256 shades. Now, what about colorful display? We have also byte per subpixel. How many shades will be for red? Folks, the same as shades for gray. So that will be 256 for red. Definitely the same number for green, 256 for green, and 256 for blue. But now every shade of red can be connected to every shade of green, to every shade of blue. Can we calculate total number of colors? That will be 256 shades of red, multiply by 256 shades of green, multiply by 256 shades of blue, and totally, folks, that will be 16.7 million. Why we multiply? Because every shade here could be corresponding to every shade here and corresponding to every shade here. So every multiplied by every times every. That will be 256 by 256 by 256. Folks, I can rewrite this with this way. 2 in the power of 8 multiplied by 2 in the power of 8 multiplied by 2 in the power of 8. That is the same result, 16.7 million. But I can say that will be 2 in the power of 24. And that will be the same 16.7 million. So, folks, in the computer technology, this kind of color named 24-bit color. Is it perfect color? No, it's not perfect. I'll tell you why. Because human eye can distinguish about 4.8 billion colors. And that is human. And that is computer. So definitely computer engineers tried to make possible display that create images with more possible colors. So folks, I changed the page and now we can see that human eye is much capable for color sensitivity. And people from the computer engineering, they try to make their computer display and computer digital camera to be the same sensitive as a human eye. How to do this? If we have these subpixels, every subpixel is connected to 1 byte, as I said. One is red, one is green, and one is blue. But what if we connect it not to the byte? What we connect it to the bigger number of bit? Let's say that will be not 8-bit like a byte, but we add 4-bit more. So total amount will be 12-bit. How many shades of gray in this case this little subpixel can display? We spoke that if we have all these zeros, that will be 1, 2, 3, 4, 1, 2, 3, 4, and another 4. So that will be totally 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Totally 12-bit. We know that the brightness of this subpixel will be in variations from all zeros to all ones. And we can make all 12 ones. 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. 12 ones. For the all zeros, that will be black. For all ones, that will be bright red. And I will put bright red here, so you will see my bright red. Question: how many combinations in this case? So folks, we need to calculate. Q will be equal to 2 in the power of 12 in this case. 2 in the power of 12. Let's say we have 2 in the power of 8, which is 256. That will be 256 multiply by 16. And I will tell you how many combinations it will be. 4096 combinations for the red. Folks, if we make the same color for the green. That will be separate 12-bit. That will be the same for 096 combinations. And for blue, that will be the same 2 in the power of 12. That will be for 096. So to calculate, that will be for green, that will be for blue. And I will tell you folks that when you buy a digital camera, then you need to watch the specification. And if the specification said that this is 36-bit color or 12-bit per color component, that will be a good camera. So now what we need to do, we need to multiply 4096 for red, multiply for 4096 for green, multiply for 4096 for blue. Let me do this quickly. 68 billion colors, approximately. So folks, 36-bit color gives you opportunity to display and to see real life colors. I would like to tell you that 24-bit color that I told you folks utilized 1 byte per color, named also true color. Its old name, true color. Of course, 24-bit color. This name is quite old, so it's not a really true color. But if we're talking about 12-bit per one color component, like 12-bit for red, 12-bit for green, 12-bit for blue, that will be a really super colors, folks. 68 billion, almost 69. But this kind of color is utilized in super professional digital cameras or super professional display that usually used for desktop publishing. So folks, now I would like to introduce the problem that could be on exams. Consider that this is a telephone and you have a display for this telephone which is resolved to 100 by 800 pixels. 200 by 800 pixels. So this is resolution for this display. I can make a little frame for this. And this display also true color. Question is, what is the file size? Is the file size, which file size? For the picture, you made a picture, you made a photograph on this display, and the picture is displayed. What is the file size inside of this telephone? Folks, this is a question. How to approach, how to make the result? First of all, we need to calculate the total number of pixels. That will be 200 times 800, that is the entire square. That will be 16 and 4 zeros, 160,000 pixels. Now, if this is a true color, each pixel contains red, green, and blue subpixels. So we need to multiply by 3 because each pixels contain 3 subpixels. So what we need to do? We need to take 16 and 4 zeros and multiply it by 3, and that will be 4,800 pixels. 480 pixels, and every pixel and subpixel actually. So we have 480 and 3 zeros. That is 480 byte, which is 480 kilobyte. Good day, everybody. This is Professor Knizhnik with a topic of networking. Networking, folks. The dream of all computer designers was to connect computers together. So if this is one computer and this is another computer, that was idea of get them together. What for? First, to increase the capacity of calculations and to increase the capacity of the storage. But most of this is to exchange files. And computer is binary device, we already know that. So computer can send information binary form, like 0 and 1. In a time frame, that could be like this. So pulse is symbolizing ones, and absence of pulse is 0. So we'll go this is 0, this is 1. This is 0, 0, this is 1. This is 0, this is 1. But at the time when the first network was actually invented, that was only telephone line. So to connect this binary information to telephone line was actually not quite fruitful, because telephone line actually works with the sound. So how to work with the sound if we have binary pulses? Then people designed such an idea named modulation, and they made this. Absence of everything is 0, but the tone, like this 2 sinus, is 1. Then absence is 0, and the tone 2, and another one 2. That's already sound. Look at this. Presence of the sound is 1, absence of the sound is 0. But to make this looks like that, we need to have the device. The process itself named modulation, because the sound is modulated accordingly to the binary information, modulation. Then, to make this sound to be received and converted to the sequence of pulses, meaning sequence of ones and zeros, we need to convert this information to the information that being sent like this one. 1, 0, 1, 0, 0, 1. And this is 0 and this is 0. So we need to convert it. And that is easy to do. So that is named demodulation. Demodulation. So folks, the two devices, one of them which is modulate, another one is demodulate, can send it to the phone line. Phone line, folks, is very low frequency and a low capacity phone. So the speed of communication was pretty small. But we need to have two devices to connect. One of them is computer and another one is modem. Folks, you heard this name, modem. Modem is modulator, demodulator. It's two functions in one device. And binary information, binary goes to modem, and tonal, compatible to telephone line, goes to phone line. Okay, from time to time, the speed of telecommunication became higher and higher, and instead of phone line, people start using the cable line and use fiber optic line. Cable, folks, use the same principles, modulation, but the speed of communication is much higher. By the way, I said speed of communication. What is velocity? How to measure it? Velocity, folks, measured in beats per second. And if you subscribe for, let's say, cable modem of Optimum now suggests you the speed of communication 100 megabit per second. It is much higher than the modems of, let's say, 10 years ago. 100 megabit. But folks, there are some communication lines that accept gigabit per second. Now, fiber optics. What is fiber optics different comparing with modem? Fiber optics, folks, is a glass tube. It's a glass tube. I will draw a glass tube like this. So it's a tube. And the light which goes to this tube never can go outside, so it's reflecting from the walls of this tube, and light go to the recipient. And this is recipient. So do we need the fiber optics modem? Definitely. Because binary signal from the computer, binary signal, much goes to the fiber optics modem, which actually convert binary electrical pulses into the pulses of light. because fiber optics, folks, meaning optics, meaning light. Optical device that dealing with light. So that is, folks, how computer generate telecommunication signal. Now, if we have computers, that is definitely good idea to connect them more than one together. And I will connect them both, and 3 and 4 and 5. Eventually they will be connected to one line in a circle. What is good? It's a cheap and simple, but what is bad? If two of them busy with communication, other computers cannot communicate with each other. By the way, this type of communication named ring. Another name is token ring. Token ring. So people who designed the communication for this computer, the schematic diagram or topology is a map of communication, they actually consider that between 2 computers and 3 computers must be something playing role of post office. So let's make this is computer 1, this is computer 2, okay? And that is computer 3. How make them communicate successful with each other? So we need to have bigger communication center. So let's say communication computer, and all 3 computers will be connected to this central computer. Assume this computer is servicing all of these 3, it named server. Type of communication like this named star. And what is the advantage, folks? Advantage is that server actually serving, it's a fast computer, so the velocity of this computer is big enough to serve all 3 and maybe 4. So I'll put 1 more inside and 1 more here. So that is star connection. So for example, computer number 1 said, I would like to send message to computer number 3, and server will handshaking with number 1 said, send message to me and I will resend it to number 3. So this is middleman. Server is a middleman computer. But folks, what's happened if we have another region with another server with other computers connected to it? I will make star like this. How to make this connected? If I would like to 1, 2, 3, 4, 5, and this is 6, 7. If computer number 1 would like to speak with computer number 7. How to do this? Can I send directly to server number 2? This is server number 1. No, that is also will be server in between. So that will be servers connected to the servers. And let me redraw this picture so you will see a little bit better to understand how it works. That is server, and that is computers for star communication connected to it. That is another server, and that is workstations or local computers connected to it. To connect them together, we need a bigger server and connect to the server. What's happened if I have another local network with computers like this, server, and another one like this? So folks, that will be the same thing. Now, how to connect these 2 servers? If I would like to connect this one to that one, we need the bigger server, and that will be like this. So, if this is star communication, that diagram named hierarchical. Hierarchical. Folks, the small connection to the server, it's a local area network, LAN. Why it's local area network? Because it's locally connected inside of the room or inside of one building, something under one roof. But this already big regional servers that connected, that could be probably a Brooklyn server, that could be New York City server, and then if we continue that will be higher server and higher server and more powerful server. Eventually that will be entire national United States of America server. So hierarchical, it's a pyramidal type of communication, and the top will be like president, that will be general big super duper server, and that will be local people or privates or soldiers or students, if this on the top is president. Hierarchical. So folks, how these computers know what to do in the connection? They don't know. They need to be programmed to behave when they connected online. And local area network actually utilize so-called protocol. Protocol. Folks, protocol is a program that tells computer what to tell and how to behave online if other computers request something or suggest something. It's like human protocol. When you see somebody, you need to say, hello, how are you? What's your name? Definitely, protocol has the alarm situation. When you say somebody, hello, how are you? And this somebody said, no, I'm going to kill you. So you need to turn around and run away. So folks, protocol. Protocol for the local area network named Ethernet. Ethernet. So cable that connect all of these computers to the server is Ethernet cable. When you connect few of your computers to the Ethernet cable, that will be internal local area network. Now folks, when we're talking about connection of the servers like this and like this, so big servers, that already must be at different protocols, because that is between cities, between regions, between countries, and that was developed with big problems. And I would like to tell you now, folks, how it was developed and what the political trouble made possible to create system of telecommunication between countries or internet.